Thank you very much for inviting me. I'm honoured to be here today. So my name is Tony Kay, and I'm a Senior Principal Architect at Red Hat. I'm a global lead for AI. And what I want to talk about over the next 30 minutes is the rise of Agentic AI. And it's going to impact you in many ways. It's already being looked at by a number of networking vendors. It's definitely going to impact security, both in a good way and in a negative way, because autonomous agentic AI is as useful to attack infrastructure as it is to defend it. Okay, but before we look at what's coming, let's have a little bit of a recap. So the last couple of years, we've seen this tremendous rise in interest in generative AI. I mean, how many of you are actually using generative AI? I'm sure more of you are using it than that. And this can be at a personal level. So I do a lot of speaking, and I meet a lot of people from companies who are using shadow AI. They're using AI tools, generative AI tools, ChatGPT, Claude, Sonnet, increasingly Perplexity, etc., in their day jobs. Copilot, most of the software developers I know are generally using it. I can't really talk to network automation specialists because the last time I ran networks, it was SNA and X25, so you can probably tell it's been a bit of a while since I've actually, since I've run some. So what are the problems? We were very impressed when GPT 3.5 came out. I think that was the eye-opening moment for many of us. And then very rapidly, we saw problems like hallucinations, problems like the lack of access to company data or infrastructure-based data. So not long after that, along comes RAG. And people start applying RAG to retrieval augmented generation. So we might take our documentation, support documentation, practices, procedures, product information, our sales information, marketing, and put it into vector databases and add that to the context of our queries to large language models. And this started to address some of the problems we saw, hallucinations, for example. One Google model was famous for benchmarking as 29% of its predictions were hallucinations, or its generations were hallucinations. So RAG started to address that, but it doesn't address many of the problems that you have with infrastructure. It's very unlikely that your logs and your live data are actually embedded within any RAG-based systems. So this is really sort of generative AI 1.0, 1.1. Other issues we have is the training data was in the big frontier models. By that I mean the GPT family, Claude Sonnet, Llama, Gemini. A lot of that, we don't actually fully know the full training data sets, and a lot of the data was copyright. So typically people use Common Crawl, and then they supplement it with more data. And this again presents a challenge for enterprises to actually use this in production. And we have customers who will not use these models at all for things like code generation, for the fear of contamination. And open source, I could talk about open source LLMs for ages, but we've got 30 minutes, so I won't. But open source LLMs are going to be one of the big features of 2025. True open source, and you should ask yourself what that actually means, because open source should include the training data itself. So, RAG, AI engineering frameworks such as LangChain, Llama Index, prompt engineering, what are they actually doing? They're actually influencing the prompt and the context, the inputs into the LLM. And that is where we're going to see huge changes coming with agentic AI. So we have this concept that we can push data into our LLM. Probably, some of you are developers, you probably remember when you wrote Hello World. Well, the Hello World in generative AI is, what is the capital of Romania? You know, you send it this very, very simple query, perhaps to an OpenAI endpoint, whether it's run by OpenAI or it's just another LLM runtime running a different model, and you get your answer back. But virtually everything you do today with AI has huge manipulations to your prompts and to your contexts. So context is very, very important. And if you see here, I'm not going to go through this code, don't worry about it. But you see here, we're not just sending hello world. We're not just sending what is the capital of Romania. We're sending a lot of data, a lot of context into the model. But that context is always frozen in time, even if it is RAG-based. So, and here's an acknowledgement as to the importance of context going forward. In the last 2 years, from ChatGPT 3.5 over on the left, where they had a context window of 4,096 tokens, which is about 3,000 words. We're now at 1 million. And we know that Gemini's been tested with 10 million. So you can see in this short space of 2 years, this huge increase in the ability of large language models to consume vast numbers of tokens. And that has an impact for you, because it's going to go across your networks for each LLM. And we're going to move away from having a single LLM very, very quickly. We're not going to go into 2025 where you talk to one LLM, because there's not going to be one LLM which meets the needs of your business. So what's going to happen? So I'm going to cover, these are all the things we're not going to talk about, but you're going to see an increasing democratization of AI and large language models. You're going to see open source models. And while I'm here in Romania, I'm here for the week, I'm going to be talking a bit about making fine-tuning more accessible. Right now, fine-tuning is the domain of the data scientists. And Andrew Nings has a great quote where he says, to be good at ML ops, you need a master's. To be good at machine learning and deep learning, you need a PhD. And there is this barrier for organizations like your own to take a model and fine-tune it to the needs of your business or to the needs of an aspect of your business. Because do you really want the same LLM doing your customer service as understanding your network infrastructure? Do we really want an LLM which understands the DNA of a lizard and can do obstacle avoidance? So that's a big area. The next thing is these big monolithic systems. So ChatGPT, Claude Sonnet, they're monolithic. Typically a chat client, a little bit of state, talking to a single large language model. And we could argue whether a mixture of experts are one large language model or not, but that has been the model. We're increasingly seeing the desire to have many large language models and not so large, small language models. If you want to push something out to the edge, you do not want to push a big model out necessarily. And you do not want to deal with the inference cost and the GPUs of running a large language model. Far better to have a much smaller, compact, domain-specific model, whether it's core or in the edge. Take a networking log. That is a domain-specific model which does not have to be too large. Another area is the transformer architecture. So if you think about it, when you ask a question of an LLM today, write a poem about a cat, it doesn't think. It just says, the cat, and it starts generating. It doesn't know where it's going. So I'm assuming a lot of you went to college, That's probably not how you wrote your essays. Well, maybe you did. Maybe you did. Maybe you didn't know what the conclusion was, and I wrote my essays the night before, and I'd be hammering away, but I would be trying to get to an end goal. So that is one of the problems of the transformer model. It is very much token-driven, and each token helps determine the next token. We're going to see more assistants, and I remember that word, more sales bots, co-pilots, GPTs as they're called. And we're going to see in this one, I'd love to talk about, and don't read it too quickly, it doesn't say casual AI. The first time I saw an article, I thought, what's casual AI? This is causal AI. So right now, when you look at ChatGPT, it doesn't actually understand why, if a link goes down, this happens. It can see patterns, but it's not cause and effect. And a lot of work is going into cause and effect models. In other words, when this link goes down, it truly understands what the impact of that will be, rather than statistically making a prediction. But the most interesting thing I think that is happening in AI right now is the rise of agentic AI. And it's going to impact all our businesses. And I think for you in particular, it's got a number of applications. So let me just introduce, how many people are familiar with agentic AI? Okay, good, good. Okay, so the first thing is, there's a little bit of abuse of the term, okay? So there's two different meanings of it. I said remember that word assistance. Google, Salesforce, and others are using the term agent, like sales agent, support agent. This is not what I'm talking about. I'm talking about autonomous systems. So when you hear agent used in that context, it's really much closer to a co-pilot or an AI which performs a role that perhaps you have in your organization, like a support bot. Now, it could be agentic inside, but this is not what we mean. So what do we mean? So agentic AI, I'm sorry to say this, but I think Terminator is a classic example of a autonomous agentic AI. And so are those, if you remember the start of Terminator. I know it was 40 years ago, but I'm sure some of you have seen it. Those are autonomous AIs. So the first thing is reasoning. So large, and we'd have to go for a coffee shop or a beer to determine what reasoning really means. But in the context of AI, reasoning, being able to look at a problem and reason a way through it. So it doesn't go through it in a procedural manner. It looks at a problem and it reasons. The second thing, planning. A router goes down. It plans what to do. Or an event happens in your network, or an event happens in my infrastructure. It gets the event, it gets the result of the event, and because of the result of the event, it changes what it does next, which leads to what we call adaptive execution. So increasingly we see large language models which can execute tools, function calling and tools. So we can provide certain large language models with a bunch of tools, and they can decide which tools to use. And on the responses from those tools, they can then decide which tool to use next. So that is that's something which a tremendous amount of work has gone in. And actually, I didn't come here to plug my parent company, IBM, but yesterday, IBM released the Granite 3 models, and some of those have been optimized for this behavior. So function calling, improved reasoning. Reasoning, you can think of this as orchestration and flow. And then the final thing is memory. And that is, if I am talking to one of your network devices, I see conditions, I call another tool, maybe I open a trouble ticket, and I query something else, I need short-term memory. so that all my tools can have shared state and see what's going on in the situation as it evolves, as we go through this arbitrary execution. And in some cases, I will need long-term memory so I can reactivate a flow and carry on where I was before. And we're seeing this already in a number of frameworks. So looking at it a different way is a schematic. So there on the left, you see tools. So we've got nice ones. So I took this literally from a great article. I'm going to share you some resources with a QR code at the end. But for all of you network specialists, you could imagine a series on the left-hand side, networking tools. And the nice thing about these tools is they can be written by people who have a non-AI background. In fact, you probably already have some of these tools, and you can incorporate them. I mean, a tool could just be a wrapper around an API call. It could be a wrapper to, I was going to say SNMP, but maybe you guys don't use SNMP. I'm very out of date. And there you have this flow. You have the memory, you have the planning and the action, and the tools. And this diagram absolutely matches what we just saw. So this is a great introduction, by the way. What are AI agents? And this is Maya Murad from IBM. Again, I'm not trying to plug out IBM, but she does a great job of explaining in about 12 minutes and giving an overview of agentic AI. Okay, so let me just talk through one. So the first thing is, a lot of you have probably been exposed to AI through a chat interface. It's a common interface, Perplexity, Claude Sonnet, GPT, obviously, co-pilots, etc. But there's absolutely no reason why these things have to have a chat interface. It's very, very useful if you've got a support engineer trying to deal with a customer problem, or increasingly an AI support engineer, but it could just be an application sitting in the background, looping, monitoring, observing state. And then the key part is an LLM with the agentic framework on top of it, which does the orchestration. So remember, it has that reasoning and planning ability, and it's aware of these tools. And you can add tools. And the tools themselves could be agentic. So you could have agents calling agents, but let's not make it too complex. And then the agent will talk to different things. And one of the key things is they can talk to the systems of record. I mean, your Salesforces, your CRM systems. So one of the problems we had before when we had those RAG systems and those LLMs, the LLMs went out of date before they even went into production. They go through all their training on frozen data with a cutoff date. The RAG systems might bring them more up to date, but you're not going to put your pricing in there. And I would suggest that if you do put your pricing in your RAG systems, that's one, a bad idea. It is a bad idea. And two, it's going to go out of date. So you can call your system, including your network devices, and talk to them. Feed them in, and then because you have adaptive execution, you can continue to iterate on the flow. Okay, so I just want to talk about a few frameworks. If you wanted to get started, this is very much an evolving space. Now you could write an agentic framework in pure Python. Absolutely, and it's not actually that hard. What's harder is to have a large language model which can do the orchestration. LangGraph is one of the big entries. Some of you may have heard of LangChain. So LangChain is an AI engineering framework. In fact, so it sits high up the stack, way above machine learning and PyTorch, etc. It's for people who are writing business applications with AI. It's a great framework. They have LangGraph, which uses graph theory to control its agents. Crew AI is built on top of LangChain. It's got a very clean interface. Autogen from Microsoft, there's another platform which has this ability to orchestrate agents. And these are not the only platforms, but these are probably three of the best known. And then you have platforms like Flowise, which sits above that and abstracts it and makes it much more graphical for development. So if you do want to get started, and you can get, who's got Python skills? Okay, Pythonists, go to deeplearning.com, and I guarantee you, in an hour's time, you will have your first Agentic AI running. Andrew Ning's got some great courses over there on deep learning. Okay, I was going to give you a demo, but given the time, it looks like we won't be able to see the demo, but there is an example. So you spend, sorry? You want to see the demo? Okay. Can somebody hand me a microphone? Okay. I will only take a moment to do this demo. Thank you. Thank you. Okay. Demo time. So can you see that? Okay, that's the Jupyter Notebook. And right at the top, I have a prompt. And I've expressed it in English. I want to know the state of 4 provisions. So I do a lot of cloud provisions on AWS and GCP, on Kubernetes. So I'm just going to click here, and hopefully we will actually see an Agentic AI in action. So I've told it, it's got 10 iterations, and it's going to start doing stuff. So, okay, so what's it done? So it's got some provision status, and it sees that it's got a warning, so it logs it. And then the next time it sees it's got minor errors, and it logs it. More minor errors. I want a real error. Come on, give me a real error. Okay, we're going to have to run it again. I need it to find a real error, and then you will see its, hang on, you will see its, so we've got a success, so it logs it. It decided not to generate any errors today. So it's just like working with animals and children. Aha! So I'm going to walk back up here. No, I'm going, yes. So notice, so it was logging status to Slack, but then it gets an error and it opens a Jira ticket. So this is what we mean by adaptive execution. It literally, first it started off by looking at the problem, and it thinks, okay, to start solving this problem, I need to get the status, and it reaches out for that tool, and it gets the status, and then when it sees it's okay, it logs it. When it sees an error, it calls Jira. And this is very, very powerful because particularly in the world of networking, you can imagine having adaptive execution and having agentic AI which can respond to events in your infrastructure is very, very powerful. Okay.